Good morning or afternoon. This is Miss Rogers, and we're going to talk about trig ratios today. Remember that ratios is just a fraction. We talked about that yesterday on the other video. So today we're going to talk about the trig ratios. So if we remember, trigonometry is the measure of triangles. We need a triangle, and we need a right triangle at that. So we have a right triangle. And today we're going to use a Greek letter called theta. Theta, or its Greek letter form, is used when we have an unknown angle measure. It's kind of like a variable. It's like we don't know the angle measure, so we're going to use theta. So here is theta. I'm going to put him right here. I'm going to put that measure of angle right there. So there's theta. And yesterday we talked about, or the other day in our video, we talked about labeling the sides of our triangle if we know an angle. So going from the hypotenuse across, that is my right angle across, that's my hypotenuse. Going across from my angle, that is my opposite. And then going just next door, that is my adjacent. Those are going to be important things to know. So if you haven't got that figured out, you need to go back and rewatch that video. Okay? So the first one we're going to talk about today is sine, S-I-N-E, or when we use it in the calculator, it's going to be S-I-N theta, or some number, sine or sine theta. So in this case, we're going to look at what it means. Sine theta is equal to opposite over hypotenuse. Or O over H. Okay? The second one we're going to talk about is cosine, or cosine theta. Let me close those little windows out. Okay, so this one would be cos theta equals, this one's a little bit different. It's adjacent over hypotenuse, or A over H. I'm putting both so you'll see what I mean. And then the last one is tangent, or tangent theta. And we write it as tan theta equals opposite over adjacent. Okay? Notice that two of them have the hypotenuses, and the third one does not. Right? And they're all related to the same angle. Okay? So now let's talk about how to calculate with the calculator. Calculate the ratios with the calculator. So with the calculator, you should have a button, and you can use your cell phone. So number 1, sine 35 degrees. You can take your phone or your if you have a cell phone or your calculator. Go to your calculator. My phone's going to make noises. If you turn it sideways, you should see sine, cosine, and tangent. So if I type sine, looks like I clear my calculator, sine 35 parentheses and press equals tells me what the measure is, what the ratio is. And I'm going to put equals. I'm around to the third decimal place, 0.57. And if I look at the third place, I'll look at fourth. That's a 5, so I have to make the third one be a 4. There's my answer. Okay? Number 2. Let's try this one. Cosine 52 degrees. So I press the cosine button. Whoops, I got to clear it. Cosine 52, close parentheses, equals 0.61. And I look at the number past the third number, it's a 6. So I round that up to a 6. And there's my answer. There's my ratio. Number 3, tangent of 21 degrees. So I'm going to do, clear my calculator, tangent 21 parentheses equals 0.38. Now look at the fourth number. It's an 8, so I round up to a 4. And there's my answer. One more, number 4. Sine of 52. You're like, where are you 52? Yes, but that was on cosine. Let's see what sine is. So clear your calculator. Sine 52 parentheses equals 0.78. I look at the fourth number. It's a 0, so I keep it 8. And there's that answer. Pretty easy. That should give you a 100 on that assignment. Okay? So, let's find out finding the ratio from triangles. Okay? Finding ratios from triangles. So number 5. Here's my right triangle. There's my right angle. And I've got 8, 15, and 9. And I want the sine of theta. I want the sine of theta. So what is the sine of theta? That was opposite over hypotenuse. Opposite over hypotenuse. So I'm going to put 8 over 15. And I can put that in the calculator and get a decimal, or I can leave it like it is. That's as easy as that. Number 6. Try this one. And a right angle, 4, 3, 5. Here's theta, and I want the cosine of theta. Cosine was adjacent over hypotenuse. So adjacent over hypotenuse, which equals 4 over 5. I think I got room to do one more. Number 7. Draw a little triangle here. 9, 22, 15. Here's my right angle. 9, 22, 15. And I want theta up here. And I want the tangent of theta. Tangent is opposite over adjacent. So 15 over 9. That one is reducible, so that would be 5 over 3. And this would be your answer. Okay? Easy peasy lemon squeezy. If you need help, let me know. There is one more thing I need to tell you about. I'm going to go sideways right here. We have a little mnemonic called SOCA. No, TOA. This is for sine, opposite over adjacent over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And I'm sorry I messed up on the H right here. So that's the easy way to remember. SOCA-TOA. SOCA-TOA. So if you need help, let me know.